Now we're going to discuss a very useful and indeed crucial device in our study of sentence logic. This device is what we call the truth tables. We said that one of the advantages of our formal language was that all of the terms are defined without any ambiguity. And this is definitely true of the connectives. Truth tables can be used to give complete definitions of the connectives. Here we're just going to introduce them so that you can see the principle behind them and hopefully understand how they work. And in a future video, we'll delve deeper into how they are constructed, step by step. Okay. Before we start, you have to bear in mind that a sentence in SL must have exactly one truth value. That is, it must be either true, abbreviated with a T, or false, abbreviated with an F. Those are the only truth values that an SL sentence can have. Then, what a truth table does is to list all the possible truth values for a given sentence. In the case of an atomic sentence, this is quite straightforward. It is either true or false. So, here we have it. X can be any sentence. We could write any uppercase letter in its place. We could substitute X with any sentence. X is a variable, then. Each line represents one possibility. And here there are only two possible cases. The case in which X is true and the case in which it is false. So if X is a sentence letter that stands for the English sentence, Al likes to dance, then there are two ways in which the world could turn out. It could be that it is true that Al likes to dance, or it could be false that Al likes to dance. And those are the only two possible cases. Correspondingly, the first line of our truth table corresponds to the possible situation in which it is true that Al likes to dance, whereas the second corresponds to the situation in which it is false that Al likes to dance. This example makes it look like truth tables might be pretty trivial things. But don't despair, they get more interesting and more useful when we consider compound sentences, as we'll soon see. Now, every legal sentence in SL, regardless of how complex it is, can be given a truth table. So, we're going to have a table in which we're going to have a bunch of rows, and each row represents a possible case. And in each row, we're going to write either a T or an F. And whether we write a T or an F on a particular row depends on these two things, and only on them. And these things are the truth values of the component sentences and the connective joining them. In short, a truth table describes how the truth or falsity of the complex sentence depends on the truth or falsity of its components. We'll see what this means in a second. What is important to understand now is that each particular connective symbol in SL is going to be associated with a specific truth table, and that this truth table is going to give us the meaning of the symbol in SL. Okay, now we'll see the truth tables for our specific connectives. Let's start with the ampersand symbol, also called the conjunction symbol. In logic, a conjunction is basically what we in English express with the word and. Okay, with the ampersand, we can build sentences of this form. X ampersand Y, where X and Y can be any sentences whatsoever, atomic or compound. In a conjunction, each of the component sentences is called a conjunct. So here, X is the left conjunct and Y is the right conjunct. A truth table for conjunction describes how the truth or falsity of the whole sentence depends on the truth or falsity of its conjuncts. So in the case of a conjunction of the form X ampersand Y, we have four possible cases. The first case is when both X and Y are true. The second case is when X is true and Y is false. The third case is when X is false and Y is true. The fourth case is when both X and Y are false. The truth table for the conjunction assigns a truth value, T or F, to each of those possible cases. It tells us that the first row gets assigned a T and that the rest gets assigned an F. And you can see how this makes sense. Remember that the ampersand is supposed to line up with the English word and. So, suppose that X is Peter went to the show and Y is Mary went to the show. Now, the sentence Peter went to the show and Mary went to the show, or what is the same, Peter and Mary went to the show, is only true if it is true that Peter went to the show and if it is also true that Mary went to the show, which corresponds to the first row. Consider the second, in which it is true that Peter went to the show, but false that Mary did. In this case, the sentence Peter and Mary went to the show is false. The same goes for the third row, in which Peter did not go to the show, but Mary did, and to the fourth row, in which neither of them went to the show. You can see that the only situation that makes the sentence Peter and Mary went to the show true is the first one, in which both of the conjuncts are true. In all the other situations in which there is at least one false conjunct, the sentence as a whole comes out false. So, in short, x ampersand y is true whenever x is true and y is true, and false in every other case. The next operator is the tilde. The tilde is the squiggle that you see here. It is also called the negation or denial operator, and it is used to model English expressions such as not, and it is not the case, and all the ways in which you could explicitly deny the content of a statement. So, for instance, if x is Al went to the show, tilde x would represent it is not the case that Al went to the show, or more briefly, Al didn't go to the show. The truth table that defines the behavior of the tilde is as follows. Remember that we're only dealing with one sentence, so we only have two possible cases. X is true and X is false. What the tilde does is simply invert the truth value of the sentence it applies to. So if X was true, then now tilde X is false. And correspondingly, when X is false, tilde X is true. And that makes sense as well, right? If it is true that Al went to the show, then it is false that Al didn't go to the show. And if it is false that Al went to the show, then it is true that Al didn't go to the show. So in these cases at least, the tilde does a good job at modeling English negation. The next connective is the V, also called disjunction. In a disjunction, the two component sentences are called disjuncts. The V is meant to model the English or either or. Though, as we'll see in a moment, there are some complications that we have to keep in mind. Suppose X is Al went to the show, and Y is Beth went to the show. Then X VY is Al went to the show or Beth went to the show. Or either Al went to the show or Beth did. Or any other of a number of possible ways of saying the same thing. Okay, let's do the truth table for the V. The V is a binary connective, just like the ampersand. Binary means that it joins two sentences. Unary means that it involves one sentence, like the tilde. So, since it is a binary connective, there are four possible cases. The same possible cases as in the case of the ampersand. Instead of starting at the top, let's start at the second row, and we'll leave the top row for last. So in the second row, X is true and Y is false. So this tells you that Al went to the show, but that Beth didn't go. In this case, X VY is clearly true, since it is enough that one of the disjuncts be true for the whole sentence to be true. The same applies to the third row, in which the truth values are inverted with respect to the previous one. Now it is X that is false and Y that is true, so that Al did not go to the show, but Beth did. Obviously, Al went to the show or Beth went to the show is also true here. What about the last row? Here both rows get an F, which means that Al didn't go to the show, and also that, well, Beth didn't go to the show either. It is clear here that the sentence Al went to the show or Beth went to the show is false, because it requires that at least one of the people mentioned, well, go to the show, and neither of them went. Okay, these are the easy cases. Now to the first row, in which both disjuncts get a T. Is XVY true or false? Well, it depends. It depends on how we understand the word or. In English, or has at least two uses. One of them is what is called the exclusive use. In this use, exactly one of the alternatives has to be true. It can be the case that both are true or that neither is true. For instance, if they tell you at a school cafeteria that for dessert you can have ice cream or fruit, what they're telling you is that you can have only one of them, so that if you have both, you wouldn't be complying with the instruction. This is an example of the exclusive use. But there is also the inclusive use, in which at least one of the alternatives must be true. So the whole disjunction is true when exactly one of the disjuncts gets a T, but also when both are true. And this is the key difference with the exclusive use. An example would be an advisor who tells you you can satisfy the language requirement by taking French 1000 or by taking German 1000. Here, taking one of these courses allows you to satisfy the requirements, but if you take both, you're also fine. What is crucial is that you make at least one of the alternatives true. So this is the inclusive use of or. Now back to our truth table. If we took the V to stand for the exclusive or, then the first row would have to get an F. But if we take it in the inclusive sense, then it gets a T. In fact, the convention in sentence logic is that the V stands for inclusive disjunction. So that our official truth table for the disjunction is as follows. XVY is true in the first three rows, and false only in the fourth row, where both disjuncts are false. Or more compactly, XVY is false only when both disjuncts are false and true elsewhere. The reason that logicians choose the inclusive sense is that it makes for a more elegant and economical system. For instance, if you compare the truth tables for the V and the ampersand, you can see that their truth value arrangements are the mirror image of each other. They're called dual operators in technical jargon. However, this introductory video is not the place for discussing these reasons. Remember that compound sentences can themselves be composed of other compound sentences. So you can start with an atomic sentence and then apply a connective to that sentence to make a compound sentence. Then you can take these compound sentences and join them to other sentences to make more complex compound sentences, and so on. In theory, you could go on forever. This means that we're going to see sentences that have more than one connective in them. Let's begin with a simple example. Suppose we want to represent the sentence, Peter will go to the show and Mary will not go to the show. Let P stand for Peter will go to the show, and M for Mary will go to the show. Ultimately, Peter will go to the show and Mary will not go to the show will be written as P ampersand tilde M. How did I arrive at this result? The first step was to take stock of the atomic sentences we are given, which in this case are P and M. Then I represented the right side part, Mary will not go to the show, which I simply did by placing a tilde next to M. The third step was to conjoin P and tilde M to form Peter will go to the show and Mary will not go to the show, like this. Notice that although there are two operators here, they don't have the same status, as it were. In fact, each SL sentence has a main connective. This is the connective that determines which kind of sentence it is, whether a negation, a conjunction, a disjunction, or what have you. So, although our sentence has an ampersand and a tilde, the main connective is the ampersand, since this sentence is best described as a conjunction. It does contain a negation, but it only applies to the right side part of the sentence and not to the whole, so it has a sort of auxiliary role. So we could describe our sentence as a conjunction in which the right conjunct is a negation. You can test your intuitions as to which connective is the main one by checking against the mechanics of formula building. The main connective is always the last connective we add to the sentence. In this case, you can see that the ampersand was introduced on step 3, our last step, whereas the tilde was introduced in step 2. To see the difference between having the tilde or the ampersand as main connective, consider the English sentence, it is not the case that Peter will go to the show and Mary will not go to the show. Or its more natural equivalent, Peter and Mary won't both go to the show. Here the main operator is the negation, since what the sentence does is basically deny the proposition that Peter and Mary will go to the show. This is how we could build it. First, we build the conjunction that is going to be denied, P ampersand M. Second, we apply the negation symbol to that whole sentence. So we can see that the tilde is the last operator to be incorporated, and the resulting sentence can be characterized as the negation of a conjunction. So the main operator is the negation. The parentheses are very important, since they are needed to ensure that the negation applies to the whole sentence, and not only to parts of it. If we leave parentheses out, we end up with this. But this is very different from our original sentence. Here, by default, the tilde only applies to the left conjunct. And what it is saying is that Peter will not go to the show, but Mary will go to the show. So, don't forget to add your parentheses. Okay, here's an exercise. Try to identify the main connective in each of the following SL sentences. I suggest you pause the video and think through the examples. I'll give you a couple of minutes. Ready? Okay, let's go through them together. The first three sentences contain only one operator, so they're trivial to identify. 1 is a conjunction, 2 is a disjunction, and 3 is a negation. The remaining 5 contain more than one operator. In number 4, the main operator is the negation, since it is the only one that applies to the whole of the sentence, and it is the last one to be added. To see it more clearly, let's build the sentence step by step. The first step is to build the disjunction A-V-C out of the two atomic sentences. And the second is to apply the tilde to the whole disjunction, like so. Remember to use the parentheses. So here we have the negation of a disjunction. It is useful to compare 4 with 5, since 5 is what you get if you omit the parentheses from 4. Now the tilde only applies to A, and the main connective is the disjunction. So the sentence is a disjunction, in which the left disjunct is a negation. In 6, we find two negations, and the main operator is the leftmost one, since that one is the last one that we add. In 7, the main connective is a disjunction. The left disjunct is A, which is an atomic sentence. However, its right disjunct is itself a compound sentence, which happens to be a negation, in particular the negation of a conjunction. So the steps for building it are: join C and D with the ampersand to form C ampersand D. Apply a tilde to the hold of C ampersand D. Don't forget the parentheses, so that the negation applies to the whole sentence and not just to the left conjunct. Finally, use the V to join the atomic sentence A and the compound sentence tilde C and D. So, as you can see, the whole sentence counts as a disjunction, whose left disjunct is an atomic sentence, and whose right disjunct is the negation of a conjunction. In sentence 8, we have many operators, but the main connective is the ampersand. I'll let you work the details out.